So we are starting here our first chapter or first topic. We'll say the numerical methods. I give a numerical methods part 1. I divide this topic into two parts mainly. The part 1 that we have solving the algebraic and simultaneous equation, and part 2 then we have some interpolation there. Actually there are three parts. There will be one more that at the end we have to use numerical methods there, numerical methods to find the area, volume. We'll come to that at the end of the topic, which actually you require later on in other subjects also. Okay, so that last article is mainly you are using in your other subjects there. I will tell you that time only. So here numerical methods that we have, the first part. Okay. So today's topic that we have is solution of algebraic and transcendental equations. Okay, we have three methods under it: bisection, regular falsi, and Newton-Raphson method. Now if you observe, I given this is in the notes also, whatever the PDF I shared with you. This bisection method, regular falsi, and Newton-Raphson. These three methods together have the 5 marks weightage in the final examination. In final examination, definitely one question will be there from these three methods. Out of that, most important is a Newton-Raphson, then uh, the regular falsi, and bisection is a rarely asked in the exam. So like that, the reverse order, the methods are important. We'll go to these methods one by one. So before we start our this topic, anyone give me the difference between algebraic equation and transcendental equation? Anyone knows the meaning of what is algebraic equation and what is a transcendental equation? Transcendental. Okay. Yes. What's algebraic equation and what is this transcendental equation? Yes, no one is there. No one giving any answer. At least you should say, I don't know.
Don't know, sir.
Don't know.
Don't know, sir.
Okay, very good. No issue. So here is that question: what is the difference between algebraic and a transcendental equation? It's a very simple definition that we have. Algebraic equation is just algebraic terms which are x raised to n, or it is in the polynomial form. Okay, that is algebraic equation. But transcendental equations are the equation which involves either, means at least trigonometric, exponential, or logarithmic term. Okay, trigonometric, exponential, or logarithmic term, if it is involved in the equation, that is known as a transcendental equation. So that's definition you will see here. The equation fx equal to 0 is said to be purely algebraic if it is a polynomial in x. It is just like in the form of x raised to n. Okay, so here is the first example: x raised to 4 minus 7x cubed plus 3x plus 5 equal to 0 is algebraic equation. Okay, this first is algebraic equation, while if the equation contains this trigonometric, logarithmic, exponential, it is a transcendental equation. So the first topic that we have, our aim is to get the roots of this equation. This is not new to you. This is already you learn in your school days that you find the roots of these equations. But generally, if the equation is quadratic or maximum cubic, it's easy to you to find the roots. But when you come across this type of equation, and if I ask you what is the root of this equation, now yes, we can find the root by synthetic division or grouping method, but instead in this topic we are going to find the roots of equation by a numerical methods. What are the numerical methods? The numerical methods are the easiest ways to get the roots or to do a calculation. But the problem in the numerical method, they always gives us the approximate values. They always gives us a approximate value. When we say approximation, there is always a error. There is always a error because suppose exact root is a 5. Suppose exact root of the equation is a x equal to 5, and if we are saying the 5.2 is the root, 5.2 is a root, then zero point 0.2 is the error there. Zero point 0.2 is error. So that is happening in numerical method. So numerical methods have certain restrictions also. We'll come to that again. So that is our aim. Our aim of the first article is just we have to get the roots of this equation by the 3 method. Okay. So now for at least for first two topics, I'm going to use a GeoGebra here. So GeoGebra is beneficial to you also later on. So for that, I want to, you should be sign up to the GeoGebra. Why you should sign up? Because without sign up also you can do it directly. When you sign up, you have your own login ID, and later on whatever you are doing in GeoGebra, everything will be saved. Everything will be saved on that GeoGebra classroom. And if you want to revisit your work on GeoGebra, you can go there. Okay, so for that I'm saying you should sign up here for a GeoGebra classroom. So steps to sign up GeoGebra. First of all, you have to click on this link. So just what I will do it, I will share this link on chat there. Actually, there is other way also. You can just type a GeoGebra classroom on Google and you can do it. Better when you have to use a GeoGebra, it's better you should do it on laptop only or desktop. If you do that, if you do it on mobile, you feel little difficulty to type sometimes. Okay, so yes, you can do it on mobile also. I'm not saying that. So click on this, everyone click on this link, and once you click on that link, you will
Sir, will you send the link?
pardon.
I'm telling, will you send the link, sir?
Already I shared the link in the chat window there. You see there. Open your chat and you will see there the link is there. Okay. Once you click on that link, first of all you will get this window, the first window. When you want to sign in, so don't type a name and you start. Instead, sign up with a Google. Sign in with a Google. So whenever you sign in with a Google, every time you will automatically get your already done work there.
Sir, but in order to actually sign in with it, we need to have an account.
No, just you click on sign in. When you click on sign in, you will get this window.
Sir, actually, it is saying this user is not linked to any GeoGebra account. Would you like
So,
to create a new account?
so you click on Google and
Sir, we clicked on Google only. In Google, it is showing, sir.
सर नीचे क्रिएट अकाउंट लिखा है वहां पे करना
okay. Those I hope all you have the Google account, na? Gmail account.
Yes, sir. Yes, sir.
So it will be automatically connect with the Google. Otherwise, you sign up there and sign up and create your account.
What should be a username, sir? Should we give a username as our IMU IDs?
It's better IMU IDs because I will also have the here.
Okay, fine, sir.
Okay.
Thank you, sir.
So I hope all you are able to do that. Otherwise, okay, just I will check it here. Is there anyone is entered there? Let I check graphing. Actually, first activity is not so. Those who are not able to do all these things, what they have to do it. just type on the Google Classroom and type this code. I think few of you already joined there, but with their names. Okay, either, okay, no issue. This first activity is not so important, so you can log in with your names, or you can log in with ID. Okay, it's better by name also, no issue. But throughout, maintain one thing only, or you can join with the names then.
Excuse me, sir.
Yes, yes.
Sir, I am telling now it has come about with GeoGebra account, username and password it is asking.
So
And
you have to sign up, na? You have to sign up. You have to create your username. You have to create your
so,
password. Or
do I have to click on create account?
yes, it's better if you want. See why I'm saying you should create your account. Later on, you will get benefit of that for remaining methods. Okay. And you want to visit GeoGebra, you will always visit there and you can solve the questions. You can solve the question on GeoGebra there. Okay, so for that you can see your previous work there. Otherwise, what will happen if you not sign up? This whatever you are doing right now, that will be removed from. Okay, you cannot revisit that. Yes, you, if you sign with your name, it's not a problem. But actually, all they are saying, they are waiting to. Okay, all once you entered, you just click on this graphing on graph paper. You click on here, click on graphing on graph paper, and you can try that. You can try it. What you have to try it there? Just click on there, task 1, and you should try the graph of y equal to x square. Okay, y equal to x square. So you can type like this: y is equal to x up cap 2. So you get y equal to x square. Classroom code is here. Here is a classroom code. Okay, I will share it on the chat again. So second activity is mainly important for you. This first activity is just starting. Okay. That is a classroom code is also shared on the chat, those who want, or you can see on the screen also. Anyone plotted the graph y equal to x square? Y equal to x square. Just I will show you how to get the graphs there. I will show you here on my screen later on.
Sir,
Yes.
so after signing up, what we have to do?
After signing up, just you have to sign in first. Sign in first.
Yes, sir, done.
Done, and then you can say classroom, Google Classroom. Sorry, GeoGebra Classroom. Go to the click on Classroom there, and you have to click the enter that code, classroom code. Okay. Here I will show you the graph. Now these things also you can do it on that first activity. Actually, I want the
Sir,
graph.
actually, there
Yes.
is some problem. Every time I click on the graph or anything near it, it's coming an unexpected error has occurred.
Okay. Yes. Okay.
Sir, what is the code?
Yes, I think everyone will get that. So I know that there is some problem in the first activity. So ignore the first activity. Okay, even though many of you are not able to do it, ignore it. Second activity is important. That time I will tell you what you have to do it. Okay. So second,
Okay, sir.
there will not be error in the second activity. The first activity, I also face some errors there. Okay. So right now, just see this my screen here. Okay, stop whatever you are doing. Everyone, stop whatever you are doing. Instead, these graphs you can plot on the second activity. Okay, so you require Google GeoGebra Classroom again after 5-10 minutes. Okay, so just see my screen now here. I want a graph of y equal to x square. So here is input screen. Input screen is on the bottom. You will see this last row there. So I will put y is equal to x square. So y equal to x square. Obviously, all you know it is upper parabola. Is that the upper parabola? Symmetry about y-axis. Now, can anyone tell me what is the root of y equal to x square? What is the root of the equation y is equal to x square? Or if I say, can I get, just I will check. No, x square. X square is the equation and it's a root. Yes, anyone? Points lying on the
Zero.
curve that are
Plus
the
or minus
roots.
one.
Either side, not correct. Someone says -1. No. So what is the root of the equation? When you find the roots of any equation, algebraic equation, for example, I want the root of equation x square equal to 0. Obviously, they are x equal to 0 only. Okay. So here this 0 is a root. Yes, 0, correct. So whenever the simple roots you have like y equal to or x square, x cube, so obviously the 0 is their root. But when we have some equations like I will say x square minus 5x, okay, x square minus 5x, let us say plus 2 equal to, okay, that's one equal to 0. What is my equation now? X square minus 5x plus 2 equal to 0. Can anyone or is plus 2 gives you
0.5 and 4.5.
yes, okay, now I will take simple roots here. X square minus 5x only. What are the roots? X
0 and 5.
0 and
0 and
5.
5.
0 and 5. Very
5.
good. So whenever you draw the curve, when the curve touches that x-axis or crosses the x-axis, that point is the root, obviously. So for x square minus 5x equal to 0, x square minus 5x equal to 0, you can solve it. I will show you here also. We have this x square, sorry, minus 5x equal to 0. That's the equation. So x is common, x minus 5 equal to 0. So we find the roots like this, x0, x equal to 5. So 0 and 5 are the roots for this equation, x square minus 5x equal to 0. This is by solving the equation, and this is graphically. Graphically, it intersects the x-axis there. The graph intersects the x-axis at that point. So this is the 0 and 5. But if you observe the previous case, now what is again what is the one more important thing in this case first, that this graph crosses the x-axis, means one part of the graph is above x-axis, other part is below x-axis, like that, below and above, okay, that way. And this type of the roots we can calculate, by all the three methods: bisection, regular falsi, and Newton-Raphson. So by these three methods, we can find out these three types of this type of the roots. But if I will show you the previous one, which is just x square. Now this second graph I here is on the in the red color. Okay, this is just a graph of x square. Here, yes, the graph touches the x-axis at 0. So x square equal to 0 have the 0 as only the root. But the problem is this graph doesn't cross the x-axis. It just touches at origin and again turns back. Okay. Now this type of the roots, if you have the equation like y is equal to x square only, and we have to find out the roots of that equation, we can compute the root of that equation by only Newton-Raphson method. First two methods doesn't work. For y equal to x square. Because of this, whenever we have to find out the roots, the most popular method, the most popular and most useful method is a Newton-Raphson method only. And that method is a most important method for us also, because majority of the times questions are coming on that. Now some of you may think how we can decide which method we have to use. So you should not worry, because each and every question is given along with the method name to you. Okay, and whenever the graph crosses the x-axis, then only the question is asked on bisection and regular falsy, and otherwise the question is on any of the method there. Okay, so you should not worry. We'll see the question that will clear. Yeah.
So can you please explain once again that Newton's Raphson?
No,
Where
we see. I'm just saying here. If you see the graph of y equal to x square, this graph, uh, this is the root. Okay, before the root, graph is on above x-axis, and after the root also the graph is on above x-axis. Okay, so whenever the equations are like this, y equal to x square, this root cannot be found by first two method, that I am saying. But you should not make it complicated, because even though you don't know all these things, then also you can do the example, because in the exam you will have the question like this: find the root of y equal to x square by Newton-Raphson method. So that will be given to you, so you can just, you have to apply the Newton-Raphson method and you get the root x equal to 0 there. Okay, but this question will never come, for bisection method. Okay, bisection method, it will never come. That regular falsy, it will never come. Okay, so for y equal to x square will never ask for bisection and regular falsy. So you should not worry about it. Because the wrong question with the wrong method will not be never asked there. Okay, so I want to say that only. Okay, come to the PPT here. We'll go to the GeoGebra after this bisection method mainly. Now, here is a first article from our syllabus, bisection method. The name itself gives us idea. It is bisecting something. It is bisecting the interval, search interval. Now, what is the first important thing for us for bisection method? Whenever we have to find the roots of the equation, it should I drawn some graph here. I drawn some graph this side. Suppose this is my graph here, and this should cross, the graph should cross the x-axis there. So suppose we have some point, say here x equal to a, and this value will be f of a then. Okay, this is x equal to a, this is f of a, and somewhere here suppose this is x equal to b, and this is f of b. So obviously f of a is above x-axis, so f of a is a greater than 0 in this case. I'm drawn the reverse graph actually. This is a reverse situation. The graph may be like that. Okay, here is downside and there is upside. So here in the graph case, f of a is greater than 0 because it is above x-axis. Here f of b is less than 0. So whenever f of a and f of b have the opposite values, then only the root lies in between there. There is a root in between. Okay, that is the indication. Now, what is done then for approximation now? So that a plus b upon 2. Okay, so general formula for iteration is xn equal to a plus b upon 2. So x1 becomes a plus b upon 2. Now just you have to add a plus b upon 2, you get some x1. Now that depending on f of x1, if f of x1 is a 0, yes, directly you got x1 as a root. Okay, otherwise f of x1 can be less than 0 and greater than 0, and depending on that we have to continue our iterations there. Okay, so I will come to the same thing with one graph here. Here is the bisection method. How bisection method works, let I show you here. You will observe the first thing, it is taken. What is taken? This is taken as a, this one is taken as b. So what is f of a? F of a is less than 0 or greater than 0? f of a is less than 0 or greater than 0? Yes. This below x-axis, na? Below x-axis, function value will be less than 0. It is above x-axis, so f of b is greater than 0 there. Okay, internet issue. Yes, Utkarsh, make me the host. Utkarsh.
Yes, sir, just
Okay. Thank you. Okay, thank you. So I don't know how much time you are not able to hear me. Whether we are
Sir,
on the same
when you
section.
showed the slides, sir.
This slide or previous slide?
Yes, sir, this one
This
only.
slide only. Okay.
this slide.
So see, first thing, what should have, this is the graph of function fx. F of a is below x-axis, so this f of a is less than 0, f of b is greater than 0. It indicates there is a root in between. Okay. Now, generally you can solve bisection example in a table form also. Now, first thing is in the table, the first column is n. What is n? N is a number of iteration. Number of iteration. A and B is the interval AB. We are selecting in the interval AB in which the function value changes their sign. Okay, generally they are two nearest integer. Generally, it is at least you have to take two nearest integer, like 0 to 1, 1 to 2, or 2 to 3. It generally happens. We have to check that. So this is a AB. Then we have to just check f of a and f of b sign. If f of a is a negative, f of b is a positive, then yes, there is a root, and we'd say x1 equal to a plus b upon 2. Now, suppose you f of x1 is positive. Right now, it is shown also. This is x1. X1, this is f of x1 there. This f of x1 is a positive. If f of x1 is positive, so tell me whether the root lies in between interval x1 to b or a to x1. Where should be the root?
Sir, X1 to B.
A
X1 to
to
B, sir, X1
X1.
to
A
B.
to x1, correct? Okay, because f of x1 is positive and f of a is already negative. So the root will not be in between x1 to b because that is both are positive there. Both are positive. So what we have to do it, whenever f of x1 is positive, that positive value is replaced by f of b is positive, na? F of b is positive and f of x1 is also positive. So b should be replaced by x1 and we get a new interval. The new interval become a to x1 now. A to x1. Again, we already observed that f of a is negative, f of x1 is positive, so we calculate x2. Now x2 is calculated with the formula a plus x1 upon 2. A plus x1 upon 2 because we have taken new b as x1 here. So a plus x1 upon 2, that is x2. Okay. Now this f of x2 is shown as negative here. This is x2 and f of x2. Suppose it is coming negative. Okay. Suppose it is coming negative. Now where should be the root in the new case now? The root will be in the
X2
interval
and
Sir,
X1.
between
Line X2
X2
and
and
X1.
x2
X1.
and x1, correct. So this is x2 and x1. Okay, so the interval goes in the the root goes in the interval now x2 and x1 because f of x2 is negative, f of x1 is positive, and the root is in this interval now. Okay, this interval. And again we calculate that x3 then with the formula that is x2 plus x1 upon 2, and we get some x3 there, and we have to say that f of x3 now. So f of x3 is not shown in the graph, but it is still assumed that suppose f of x3 is also negative. So suppose somewhere here this x3 will come. Okay, suppose this is the x3. X3. Now the new interval will be then x3 to x1 then. Okay. Again, you have to calculate x4 and so on. What is happening? What is happening? Tell me. What is happening in each case? What is happening on the graph? Or what is happening with
Sir,
this?
intersection points are getting close.
Okay, or interval is going shorter and shorter. Okay, that will
Yes,
become a
sir.
smaller and smaller. And at the end, when you take more iterations, obviously you will get closer to the root there. Okay, but still, suppose you've done 4 iteration only. and you say x3 is a root. Suppose you are saying x3 is a root, whether x3 is the exact root? No. Okay, because exact root is here. This is the exact root. But x3 is an approximate root. After 3 iteration, okay, that we can say only. Numerical method gives us the approximate roots only, and we're getting closer to we're not getting closer to x1, we're getting closer to this x star, we'll say. So x star is the main root there. Okay, x1 is just approximation again. Okay, x1 is the approximation. So when you take higher number of iterations, you get the more accurate answer there.
Excuse me, sir. So
Yes.
please explain the first two steps again.
Which first two steps?
So the beginning ones, negative and positive. FA.
It is straightforward there, but I will show you again here.
Excuse me, sir.
Yes.
Sir, do we have to make this chart which is made here?
No. This table you have to make it for the example. I will show. Graph you don't have to make it. This
No,
graph.
I'm telling this table only. Table we have
Yes,
to make
table
it.
you have to prepare it. You have to prepare the table for each example. You can do it in two different ways. I'm going to show you. Either you can do it in the table form or you can do it in descriptive form. Okay, but I prefer a table form because it is a shorten. Just you make a table and you get the answers there. It's
At
better
this
you do.
point in time, do we have to copy this table, sir?
No need, because you have already shared this now with you. This table is with you there. In the example, we'll do this table. Don't write now. It's not required.
Okay, sir. Okay, sir.
Okay. Okay. The first thing that is important is there. We should have two values where f of a and f of b should have opposite sign. So here, this f of a is a negative, f of b is a positive. So it is f of a is a negative, f of b is positive. It indicates the root is in between there, and this is the root. This root is x star. Say x star is the main root, and that we have to find it. To get that x star, what we do, x1 equal to a plus b upon 2 will take. A plus b upon 2, and you get a first. So f of x1 is, suppose it is positive. If it is positive, now see, f of x1 is positive and f of a is a negative. So there should be opposite signs, na? F of a negative, f of x1 positive. So the root will be in between ax1 there. Is it okay?
So
Okay.
Yes, sir.
Yeah. So let me
Sir, in the next part, in the step 2, sir, then why did we not take B? Because x2 was negative.
f of x2 is a negative.
Yes, sir. So we'll be taking a positive because it will be in between.
F of x2 is a negative. F of a
Is
is
also
also
negative.
negative, na?
Yes, sir.
So it is a is replaced by x2. Then
Okay. Okay, sir.
you will come to know, you will get it when you do the examples. Mainly, you'll come to that. So this is the first question for us. Solve x cube minus 9x plus 1 equal to 0 for the root lying between the 2 and 3 using bisection method in 6 stages. Now, this is the way the questions are coming in the exam. In the examination, you will find the question in this format. Now, what are the things that are given in the question? You can see here. The first thing, the equation whose roots we have to find out. Okay, this is the cubic equation. Actually, you can find the root of this equation without numerical method also, but it is already written. You have to use a bisection method only. So you cannot do synthetic division or other things there. So name of the method is always provided. Equation is provided. This part, the interval may be given, may not be given. Right now we are given the interval is a 2, 3. Okay, so and these 6 stages, this is also required. What is this? This is the last part actually. This is known as a stopping criteria. This is known as a stopping criteria for iteration, because now these are approximate methods. We are getting approximate roots. So someone can do only 2 iterations, someone can do 3. Here it is written 6 stages, means 6 iteration. We have to do a 6 iteration. So either stopping criteria is iterations, or sometimes the accuracy, like correct up to 3 decimal places, correct up to 4 decimal places. So that will be the stopping criteria in the question. Okay. So here we have to find the roots of this equation. So the solution go like this. In a solution, now one most important thing again, everyone should have the calculator. Okay, calculator with you, better the scientific calculator only for the today's and this entire topic numerical method. Okay, so every time whenever there is a class, you should keep a calculator with you. So x cube.
So please use different coloring.
Pardon,
Maybe yellow or so
okay.
maybe yellow or white.
Okay, just I will check. You will. Is it visible? This is okay.
Yes, sir. Fine.
Yes, sir.
Yes, sir, yes, sir, yes.
So let I say, let our fx is x cube minus 9x plus 1. So this is our fx. First you have to say that is whatever the algebraic equation that you are given, that is considered as fx. Now just check first what is f of 2. Calculate f of 2, which is a 2 cube minus 18 plus 1. And now we are not interested in value. We are not interested in value. We are interested in sign only. Whether f of 2 is positive or negative. 8 minus 18 plus 1.
Negative.
Negative,
Negative.
negative.
So I will say f of 2 is less than 0 and f of 3 should be greater than 0. Okay, you should check. Now you can start the table. The first column of the table is n, then the values of a and b, then the column of f of a, f of b, then the column of the iteration, that is xn, which is a plus b upon 2, and last column is f of xn. So that about the table. This table we have to prepare. Now I will say it is actually the zero iteration first, whatever. So n is equal to 1, the first iteration, sorry. The value of a is 2, the value of b is 3, f of a is a negative, f of b is a positive, and x1. Now x1 is 2 plus 3 upon 2 is obviously 2.5. So it is bisecting the interval, half of the interval removed from the search part. So x1 become 2.5. Now you have to calculate f of 2.5. Whether f of 2.5 is a negative or positive. I want the answer from you. F of 2.5.
Negative.
Negative?
Negative.
Okay, very good. So f of x1 is a negative. F of x1 is a negative. Now the most important steps come. Which should be replaced, A or B?
A.
Yes, very good. A should be replaced because f of a is also negative. F of a is negative, f of x1 is also negative. So that the root goes between 2.5 to 3. Very good. You are correct. So this is negative. This
Sir,
is,
excuse me.
yes.
Sir, in the first line, how f of xn was negative?
F x1.
F of xn.
F of xn, f of
Oh,
x1.
putting it. Okay, sir, got it.
This you have to replace 2.5 here.
Yes.
And then
Sir,
you check.
if we took one in place of two, like A1 and B2, then two would be negative positive.
Hmm?
Sir, like we
See,
took A
first
equal to
thing,
2 and
we are given an interval 2 and 3, so we have to stick to that. Actually, you will get many values where f of a is negative and positive then. Okay.
okay, sir.
So right now the interval is given, then we have to fix it here only. We'll come to other parts also whenever interval is not given, how to start with interval, that also we'll check it later on. Okay, so that about this one. So what about x2
Sir,
then?
one
Yes,
more question, sir.
yes.
Sir, in the second line, means this second one, we are writing the value of a as 2.5.
Hmm.
Why, sir?
Because interval is changed now, na? First interval is 2 to 3. And now we have to see that interval is divided into, this is the first interval. Here is 2, here is 3. We take an x1, x1 is 2.5. Now we have to check whether the root is in this part or this part. We already observed f of x1 is negative and f of 3 is a positive. This is negative and this is positive. So the root should be here. If you say 2 and 2.5, what happened? F of 2 is also negative, f of 2.5 is also negative, so root will not be there. Okay, are you getting? Just use your logic there, that what is the criteria for having the root? The root lies between the root lies in the interval provided the function changes its value, the function changes its sign, that it should be negative and positive there. Sanchit is saying this go up to infinity. What is the meaning of infinity here? Means infinite iteration? No. Because of that, stopping criteria is given 6 stages. You have to do it in 6 stages, in 6. Yes, 2.75, correct. X2 is a
F of
2.75, very
2.75
good.
is negative.
Now, what is f of x2? F of x2 is positive or negative?
Negative, negative.
Again,
Negative.
So it should be replaced now.
2.5.
Yes, 2.5 again, because f
A
of
will be
2.5 is negative. So it is a 2.75 only. So the root is continuously, now here the interval goes up to here now. So this interval is now the root is there, 2.75, 2 to 3. So that part. So this part is there always, negative and positive signs will be always there. That about x3. Now you have to check
2.875.
2.875. Now you have to check the sign, positive or negative.
Negative only.
Still negative.
Still negative. So sometimes this happen that every time the interval is replaced from left side only or right side only, or sometimes it is vice versa. Okay, or a mix there. So that way you have to continue. I'll not do there will be 2 more iteration. You have to do up to 6 times. I will show you the entire calculation directly now. Okay, just this is already a solved example. I said you on page 26 of your PDF. Just I will come to that page 26 here. Probably 26. Yes. Okay. It's not 26 exactly. It may be 20. Yes, this question. Okay, this question we are doing. So this is the way you have to complete in the exam. This is the number of iteration. These are the values of A. These are the values of B. And this is the 6th iteration. At the end of a 6th iteration, you get 2.95. 2.95 as a root there. Yes, correct, Rohan. Rohan, you are correct here. In the 5th iteration only, it is changed from upper side there. Last iteration is that. And generally, I prefer to write 4 decimal places. Someone may have the doubt in how what should be done. So there are 2 ways again. You should do up to 4 decimal places, and after 4 decimal places, you can round up also. Okay, if you want. One more important thing in the exam. Suppose 2.95 is the answer I'm getting after 6 iteration, and someone written the answer 2.94 or 2.96. That is also considered as a correct. Okay, because these errors of 0.01 can be possible because of round up or other things there. So that are considered correct. But if 2.95 is the answer and you are writing the answer as 2.8, then it is not considered correct, because 2.8 have the too much error there. So the error should be in the last decimal place only, not before that. Okay. Now, whatever
Sir,
done, yes.
sir, the x3 is positive, na?
F of x3. No, f of x3 is negative here written.
So can you check once, sir? Because x3
No,
is
I
No,
must
27.
it's
ask.
negative only. It's
Yes,
negative only.
yes, f of
Minus
x.
1.1.
Very good. So I'm. You can you just you check in the function. You have to
Sir,
replace.
x5 is also negative.
f of x5, this one, 2.969.
No, sir, it's correct. It's positive. It's
Positive.
coming 0.4458.
Sir, if we take 96875, then it's coming negative.
So 96875.
75, yes, sir.
Okay, but suppose if you are doing that way and you are getting negative, you calculate on your own way. It doesn't matter. But what is your x6 there? Tell me the x6. It should be near to the 2.95 only. Means I already told you that it should be either 2.94. It can be 2.96. Okay. So small errors are possible because of how much decimals you are taking. But because of that, for uniformity, for uniform answers, I suggest all of you should do the calculation with 4 decimals. Okay, do.
Sir,
Uh,
so we have to take that. So if we are calculating for x1, then we have to take 2.5 cube minus 9 into 2.5 plus 1.
minus 9.
So I'm telling about the first one.
Huh?
If we are calculating x1, fx1,
Correct.
then we have to take 2.5 cube
Correct. We have to.
minus
You have to
9.
replace 2.5. You have to replace
Oh,
2.5 here. 2.5 cube minus 9 into 2.5 plus 1. That is f of 2.5, na? F of x1. And this that f of x1 is negative here.
okay, sir. So I was taking that 1 only and 2,
No,
3,
how
4.
one? No.
Okay, sir. Fine.
Okay. Now the same table form. If you are not interested, write in a table form. You want to write like this. Also, you can do this way also. But this is a lengthy way. This looks lengthy here. I will show you what is done here. Here the same problem is solved in a different way. The same problem is solved in a different way here. You will observe this is our fx we already taken. This is the fx we are taken. F of 2 negative, f of 3 positive, so root is in between, so we say x0. Okay, you can write x1 also, it doesn't matter. X1 has a 2 plus 3, that is 2.5 you get. F of 2.5 you calculated, it is coming negative. So as f of 2.5 is a negative and f of 3 is positive, so the root is in between 2.5 and 3. So the initial interval is 2, 3, and that reduces to the now 2.5 to 3. So the same thing is there done here, but instead of doing that in a table form, uh, done like this. So you'll observe that 2.5 to 3, the root is there, so x1 is 2.75 is taken, then f of 2.75 check, that is negative, so the root lies between here. So that way, so same thing is like that also, you can write it. Okay, so choice is your. You can write it in a table form, or you can write like this, and after 6th iteration you can say this is the answer, 2.95312, that way. Okay, now to get this answer, to see this answer graphically, or can we take a break of 5-10 minutes and then we'll start it?
Yes, sir.
Okay, so how much break you want? 10 minutes?
Yes, sir.
Okay.
So
Okay.
10 minutes.
Okay, 10 minutes break and then we'll continue. Okay.